Okay, so let's start with version control. Think about working on a document, you make changes, save it as something new, right? Without version control, if you mess up the latest version, you can lose all your previous work. Version control, like Git, is basically a time machine for your projects. It records every single change you make, so you can go back to an older version if needed. This is incredibly useful for teamwork because everyone can collaborate without stepping on each other's toes, and it makes debugging much easier. You can quickly roll back to a working state if something goes wrong. Plus, it gives you a safety net against losing your project. Okay, let's talk about Git. Essentially, it's a super powerful tool for managing changes in your projects. It's what we call a version control system, meaning it keeps track of every single modification you make to your files from the very first line of code you wrote until today. The cool part is that every developer working on the project has a full copy of the entire history, which makes collaboration really smooth. It's distributed, so there isn't just one central server. Everyone has their own local copy. When you make changes, you commit them, basically taking a snapshot and saving it with a little note about what you did. You can then create branches to experiment with new features without messing up the main project. And finally, when you're ready, you merge those changes back in. Okay, let's talk about Git versus Subversion, or SVN. Think of SVN as a traditional system where everything happens through one central server. You check out files from that server, make changes, and then push those back up. It's like a control flow. Git is totally different, it's distributed. Every developer has a complete copy of the project history on their own machine. This lets you work offline, experiment with branches easily, and merge changes without constantly needing to talk to a central server. You can see a table here that highlights some key differences, like how each system handles repository structure and offline work. Git's flexibility is a big reason it's so popular now, particularly in teams where collaboration needs to be fast and fluid. SVN still has its place for companies needing really tight control over their codebase. Okay, let's talk about repositories. In Git, a repository is really just a special folder, a folder containing all the stuff for your project, your code, images, everything. But it's much more than just a regular folder. It keeps a complete record of every change you make, like a time machine for your project. It stores the files and folders themselves, but even more importantly, it tracks the history of those changes so you can always go back to an earlier version if needed. Okay, let's talk about local versus remote repositories. A local repository is like your personal copy of a project on your computer. It's where all your work happens privately. You can make changes, save them, and experiment without affecting anyone else. Now, a remote repository is a shared location, often hosted online like GitHub or GitLab, that acts as the central source for everyone working on the project. It's how we all collaborate and keep track of updates. Think of it this way, your local repo is your workspace, and the remote repo is where everything lives together. Okay, let's talk about how you kick things off with Git initializing a new repository. Basically, this is where you set up the whole system for tracking your project's progress. The first thing you need to do is navigate to the main folder of your project using your terminal or command prompt. Then simply type Git in it and hit enter. That's it. Git creates a hidden folder called Git which stores everything related to your repository, all the history and changes. You'll get confirmation that it's set up, and from there you can start adding files and tracking them as you go. So, when it comes to working with Git, one of the first things you'll need to do is clone an existing repository. Think of it like downloading a project but with version control. The command is simple: git clone. Just replace with the actual address of the repo, usually found on platforms like GitHub or GitLab. Git will then fetch all the files and history and create a new folder locally that mirrors the remote repository structure. It's a really quick way to get started and have your own working copy. Okay, let's talk about the Git directory. It's a really important concept in Git. Basically, this hidden folder is where all the magic happens. It stores everything related to your project's history, every version of each file, how those files have changed over time, and even settings for Git itself. It's like Git's memory bank, tracking every single change you make. You should absolutely never mess with this folder directly. Let Git handle it. Okay, let's talk about git pull and git fetch. They're often used together, but they do different things. Git fetch basically downloads all the latest changes from a remote repository. It's like checking your email to see if anything new has arrived. It updates what we call remote tracking branches, which are local copies of the remote branches that tell us where things stand. On the other hand, git pull does two things. It first fetches those changes, just like git fetch, and then it immediately merges them into your current branch. So, git pull is essentially a shortcut for fetching and merging in one step. It's convenient, but sometimes it's good to use git fetch separately so you can review the fetched changes before deciding whether or not to merge them. Okay, let's talk about branches in Git. They're super important for managing your projects effectively. Imagine you're building a house and want to try out a new design before committing to it permanently. A branch is like creating a separate room where you can experiment without altering the rest of the structure. Essentially, it allows you to work on different features or fixes in isolation from the main codebase. This prevents unintended consequences and keeps things organized. You'll often use branches for experimentation, parallel development, and ensuring stability. It's really about creating a safe space to build. Okay, let's talk about branching in Git. Think of it like creating a separate line of development for your work. You can start a new feature or fix a bug on its own, completely isolated from the main project. The command to create a branch is simple: git branch. That creates the branch locally, but you're still working on the current one. To actually use that new branch, you need to switch to it with git checkout, and then you're ready to start coding. Okay, let's talk about switching between branches in Git. It's a really fundamental skill. The main command you'll use is git checkout. This essentially updates your working directory to match the code that lives on that branch. Think of it like jumping from one row to another. Checkout means you're moving your focus to a different line of development. It's important to understand what head is doing. It always points to the currently active branch, and when you switch, it updates to point at the new branch's latest commit. Branching strategies like using feature branches can really help keep things organized as you work on new features and then merge them back in. For example, if you're working on a new button design in a branch called feature/new button, you'd switch to the main branch using git checkout main to update your work. Okay, let's talk about fast forward versus three-way merge. Is a really important concept in Git. A fast forward merge is super straightforward. It's like just moving your current branch pointer to the latest commit on another branch. It happens when your branches haven't diverged yet. On the other hand, a three-way merge comes into play when you're trying to combine changes from two different branches that have both seen modifications since they branched off from their common ancestor. This means there might be conflicting edits, so Git has to intelligently figure out how to bring those changes together, essentially creating a new commit that incorporates the best of both worlds after resolving any conflicts. Okay, so let's talk about how we bring changes from your feature branches back into the main codebase. This is called merging. First, you need to switch to the branch where you want to integrate those updates, usually main. Then, use the git merge command followed by the name of the feature branch you're merging in. If there are conflicts, Git will tell you which files have them, and it's your job to manually fix them by editing the file and then adding and committing the changes. Finally, push those merged changes back up to the remote repository. Okay, let's talk about merge conflicts. They are a common issue when working in teams using Git. Basically, they arise when you try to combine changes from two different branches that have altered the same lines of code. It's like having two people edit the same document simultaneously. Both make edits, and now it's up to you to decide what the final version should look like. Git will flag these conflicts with some special markers in your files, so you can carefully review them and decide which changes to keep or how to combine them. Remember to remove those markers after making your decision, and then commit the resolved file. Okay, let's talk about merging versus rebasing in Git. They both help you bring changes from one branch into another, but they do it differently. Think of git merge like combining two roads at a junction. The history of each road is still there. Git rebase, on the other hand, is like moving a section of road to start at a different point in time. It alters the historical timeline. They both have their use cases, and understanding when to apply them is key. Let's take a look at how they impact history, complexity, and your branch structure. Okay, let's talk about when you'd use git rebase versus git merge. They both get changes from one branch into another, but they do it very differently. Git merge creates a new merge commit which keeps the full history of every branch involved, good for auditing. Git rebase, on the other hand, rewrites your project's history as if you started fresh from the latest version of the target branch. It's great when you want a really clean, linear look to your history, especially when integrating feature branches. But it's important to know that rebase can get tricky when multiple people are working on the same branch, so, for shared branches, generally stick with merge. Think of rebase as creating a fresh start, while merge is more like layering your work on top of existing history. Okay, let's talk about detached head states. Basically, this happens when your Git working directory isn't linked to a particular branch anymore. It's like you've wandered off the main trail and are just exploring the commit history. You often get into this situation by checking out an older commit or resetting your current state. The key thing is, if you're in a detached head, you can't make new commits directly because Git doesn't know * where * to put them. It's a useful tool for looking back at past versions of your code, like recreating a specific release tag, or just diving into the history. Okay, let's talk about how you can undo changes in Git. You have a few different options depending on what you want to achieve. First up is the git checkout command. This is great if you just need to discard some local edits and go back to your last committed version of this specific file. Then there's git reset head, which effectively rolls back to the previous commit, but be careful with this one because it can alter your history. If you want a safer way to undo changes while preserving the history, use git revert commit hash. This creates an entirely new commit that reverses the effects of the specified commit. Lastly, we have git restore staged, which is useful for unstaging files that you may have accidentally added to the staging area. Remember, always commit your changes before attempting any of these operations. It's a really good habit to get into. Okay, let's tackle these git commands. First up is git reset. This one's a bit tricky because it actually changes your project's history. It moves your head pointer to an older commit, essentially undoing some of your recent work. There are different ways you can use it. Hard is the most aggressive, discarding any uncommitted changes entirely, so be careful. Then we have git checkout, which is mostly about switching between branches or checking out specific commits without changing history. Finally, there's git revert. This command creates a new * commit that reverses the changes made by an earlier commit. It's a safer way to undo things because it doesn't rewrite the existing history, it adds a revert commit on top of everything. Let's talk about removing files from Git while keeping them locally, a really important scenario. The most straightforward approach is to just not stage the file. Essentially, you're telling Git, hey, I don't want this in my next commit. You can do that using git reset head. If it's already staged, which happens sometimes, use git rm cache to remove it from the index. This keeps your local files intact, but it's no longer tracked by Git. Finally, a really good practice is always adding entries to your gitignore file to prevent similar situations in the future. Okay, let's talk about the staging area. Essentially, it's Git's way of keeping track of exactly which changes you're planning to include in your next commit. It's like a preparation zone. You add the files you want to be part of that commit into the staging area using git add. This gives you really precise control over what ends up in your project history, so you don't accidentally commit things you didn't intend to. Okay, let's talk about adding and committing in Git. It's a really important distinction. Git add is like selecting the files you want to include in your next update. It stages those changes. Think of it as putting them on a list ready for packaging. Then comes git commit. That's where you actually create the snapshot, take a picture of all those staged changes, and write a message describing what you did. It's like sealing up your suitcase with a note about what's inside. So, add prepares commit records. Got it? Okay, so let's talk about checking out your commit history in Git. The most straightforward way is simply using the git log command. This will give you a list of all the changes that have been made to your project, ordered by when they were committed. You'll see things like the commit hash, who made it, and what they described as the change, really helpful for understanding the evolution of your code. You can use some handy flags too, like one line to get a more compact view, or graph to visualize how branches are merging together. And if you're looking for commits by a specific person, you can add an author filter. Okay, let's talk about commit hashes. They are a really important concept in Git. Basically, every time you save changes to your project, Git creates a snapshot of it. And for that snapshot, it generates a unique identifier called a commit hash. It's like a fingerprint for that specific version of your code. Git uses a clever algorithm to do this, creating a long string of letters and numbers that's totally unique. These hashes are how we track changes, go back to older versions if something goes wrong, and even manage different branches in our project. They are truly the backbone of Git's history tracking. Okay, let's tackle how to change things after a commit. It happens all the time. The easiest way is using git commit amend. This lets you rewrite the last commit message directly. You can just type in a new message with the flag, or if you want to change the content itself, stage your changes first with git add, and then use git commit amend again. Remember though, this creates a new asterisk commit on top of the old one, so you'll have both in your history. Let's talk about tags and Git. They're like snapshots of your project at a particular moment. Unlike branches, which show how things are constantly changing, tags mark specific points, often representing releases or important milestones. There are two main types: lightweight tags that just point to a commit, and annotated tags which include extra information like who created the tag and when. They are super useful for tracking releases and making it easy to roll back to older versions of your code. Essentially, think of them as permanent bookmarks in your Git history. Let's talk about tags and Git. They're like permanent milestones in your project's history. Think of them as labeling important releases or versions. To create a tag, you use the git tag command followed by to add a message, then specify the commit hash you want to link it to. For example, git tag m1.01234567. Deleting a tag is straightforward with git tag d. However, deleting the tag doesn't actually remove the associated code changes, it just removes the pointer to that commit. Always double check your commit hash before creating a tag, and remember tags are generally considered immutable. Okay, so git stash is like a little secret drawer for your changes. It's super handy when you're juggling multiple tasks and don't want to commit something that's not quite ready yet. Basically, it lets you clean up your working directory, switch branches without committing unfinished work, or even just put aside some modifications while you tackle something urgent. Think of it as a temporary holding spot for those I'll get back to this later changes. You can stash them, then pop them back when you're ready, and it's a great way to keep your workflow smooth. Okay, let's talk about stashing in Git. It's like putting your code changes on hold temporarily. You use git stash push to save those modifications. You can even add a descriptive message for clarity. Now, when you want to get back to your main work, there are a few ways to bring those stash changes back. You can apply the most recent one with git stash pop, or you can target a specific stash using its index number that you find with git stash list. If you decide you don't need the stash anymore, just drop it with git stash drop. Okay, let's talk about git logs versus reflogs. They are often confused. Git log is your regular history viewer. It shows you a chronological list of all the commits that have happened in the branches you're currently tracking. Think of it as a record of what's been added to your main lines of development. On the other hand, git reflog is like a backup system for your head pointer. It keeps track of asterisk every asterisk time your head moves, whether that's because you committed something, reset your branch, or even accidentally ran a command that changed where your head points. So, if you mess things up, reflog can help you recover lost commits that aren't visible in the regular branches. Okay, let's talk about cherry-picking commits in Git. It's a really handy way to grab just *1* specific change from one branch and apply it to another without merging the whole thing. Think of it like taking a snapshot of a particular commit and pasting it into your current branch. The command is simple: git cherry pick commit hash. Just replace commit hash with the actual hash of the commit you want to move. I'll show you the syntax in code, but remember that if you apply a change that already exists on another branch, Git might create duplicates. So always review what's being applied to make sure it doesn't break anything. Okay, let's talk about clones in Git. There are two main types, a regular clone and a bare clone. A standard Git clone is like making a full copy of the repository. You get all the branches, all the commits, everything. It's perfect for when you want to start developing locally. But there's also a bare clone. This creates a sparse repository which only holds the history and references. It doesn't have a working directory or any files. Bare clones are really useful for things like creating backups or sharing just the historical information with other people. They are essentially read-only copies of the remote's history. Okay, let's talk about dealing with those massive files that can sometimes slow down our Git workflows. First and often best approach is Git LFS. It's like having a separate storage area for these bigger items. Instead of storing the entire file in your repository, LFS only keeps a small pointer to where the full file lives on an external server. This dramatically reduces your repo size and speeds things up when you clone or pull changes. Another option is simply ignoring files that aren't vital for version control using hit ignore. And finally, if those files are truly outside the core of your project, consider storing them in a cloud storage service like S3 or Google Cloud Storage. Just link to them from your Git repository. Okay, so let's talk about Git LFS. Essentially, Git, while amazing for text files, really struggles when you're dealing with big binary things like images or videos. Trying to track these huge files directly in your Git repository can lead to ridiculously large repositories and make collaborating on projects super slow. That's where LFS comes in. It's a clever system that doesn't actually store the entire file within your Git repo. Instead, it just keeps a small pointer like a reference pointing to the actual file stored securely on a remote server. When you need that big image or video, LFS automatically downloads it for you. This dramatically reduces your repository size and makes working with these files much smoother during development. So, when it comes to setting up a remote repository, think of it as your central hub for code. First, you'll need to pick a place to host it, like GitHub or GitLab. Then create an account and build the repo itself. If you haven't already initialized Git locally, do that using Gitinit. Next, connect your local project to the remote by adding the URL of the remote repository. You can find this on your hosting service's website. Finally, push your code for all of it to the remote using git push, making sure you're pushing to the correct branch and using a meaningful commit message along the way. Okay, so let's clear up a Git mystery. You'll often hear about Origin and Upstream. Origin is your local clone, the version of the project you have saved on your computer. It's like your personal backup copy. Now, Upstream represents the official remote repository, usually hosted somewhere like GitHub. When you first clone a project, your local copy becomes linked to the Upstream repo via Origin. So, Origin is your local version and Upstream is where everything else lives.